All right, well, hello everybody. This is your teacher, Mr. Santillana, and these are your notes for section 3.1. We're going to title this Lines and Angles. Please make sure that you update your table of contents when copying these notes onto your notebook. All right, let's start with the concept here. So what are we talking about? We're talking about studying relationships that are created in the world of geometry by lines that intersect. All right. So we're going to break these notes into three parts. Part one, let's go ahead and study a cube. So some of you might not know how to draw a cube, so pay attention as I teach you how. Let's start by drawing a square. Very, very simple. I'm going to put 4 dots across here. Going to connect them like so. And what a cube gives us, it gives us a series of lines that are intersecting each other. All right, from the top left corner, I'm going to extend out, maybe up a line here. From the top right corner, I'm going to create a parallel line, and then I'm going to connect them, just like that. Doesn't have to be perfect, it just needs to look like a cube. All right, from the top right, I'm going to extend down to this line, keep it straight, and then I'm going to connect the bottom. All right, now for the back end of the cube, since it's a 3-dimensional figure, I'm going to draw similar lines, but I'm not going to make them into solid lines. Instead, I'm going to dash them because they're supposed to be the back end of the cube and you can't really see them. All right, let's label our points. This corner, I'm going to label A. This corner, I'm going to label B and C and D. Down here, let's go with E, F, G, and this back corner, I'm going to label H. All right, let's go ahead and identify a couple of lines. So for that, let's identify AD as a line. So here we go, let's identify AD as a line. There we go, so there's one line. And let's identify BC as the other line. All right, there we go. And we're gonna identify EF as our third line here. Okay. And we're gonna color in a couple of planes. Let's take a look at the plane on the top, A, B, C, D. I'm talking about the plane on the top of the cube. Let's identify that plane, and then the one on the bottom, E, F, G, H. All right. Okay, so there is our cube. Now let's take a look at the learning. First of all, I gotta teach you a couple of symbols. Parallel line symbol looks like that. Intersecting symbol, when two lines intersect, well, it's a symbol that looks like a U, upside down U. All right, parallel lines, what do we mean? We're talking about lines that don't intersect and are coplanar. So notice, they don't intersect and they're coplanar. For example, AD is parallel to BC on the cube. Okay, let's take a look at this definition. So that's parallel lines. How about skew lines? These are lines that also don't intersect, but they are non-coplanar. For example, AD and EF are skew lines. Think of skew lines as lines that, sure, are parallel, but they're moving in different directions. Best way to think about them. And of course, parallel planes, planes that do not intersect. Here is the symbol for plane, ABC, the symbol for plane, EFGH, and there's the symbol for parallel. There we go, parallel planes. You can see that in the cube. Okay, second part of 3 parts, this concept of a transversal line. It's a line that intersects 2 or more lines. Why is that important? Let me show you. All right, so let's draw 2 random lines. Here we go. Boom. Make that your first line. Call that line L. And let's just draw another random line here. Call that line M. All right, I'm going to switch colors and I'm going to draw another line that's going to intersect both of these lines. Let's make it at a different angle. just like that. And we're going to call this the transversal line. So T for transversal. So the red line is the transversal line. What is it doing? Well, it's creating three different areas. For example, let's identify the angle so that we can refer to these areas. Let's call this angle right here. Let's switch colors so everybody can see it clearly. Angle 1, and over here 2, 3, 4, angle 5, 6, 7, and 8. All right, what you see in between lines L and M, I'm talking about angles 3, 4, 5, and 6. That's what you would call the interior angles. Interior angles, because they are in between two lines, right? Angles that were created by a transversal that are in between two lines. And then you have, of course, the angles on the outside. I'm talking about 1 and 2 and 8 and 7. What do you call those angles? So you call those the exterior angles. And those are the angles, right, created by the transversal that sit not in between the two lines, but on the outside, right? So you have the exterior angles and you have the interior angles. I'm going to go ahead and label it down here as well as exterior angles. All right, so now this next part has to do with this exact same diagram, but these are special cases. All right, I call this part 3 of our notes, the last part. There are 4 special cases for a transversal line. What if the lines it intersects are parallel? So I'm going to highlight this question because this is what this lesson is all about. What if the lines, right, are parallel? Let's take a look at the first of these 4 scenarios. We call this alternate exterior angles. You can see that line L and M are going to be parallel. So I'm going to use the parallel symbol, which looks like this. You draw a little triangle on top of the line and you shade it in. You draw a little triangle. Again, what does this symbol represent? This symbol represents symbol for parallel lines. All right, so line L and M are parallel. You can see that we have angles 1, 2, 3, and 4 as the exterior. What does that mean? Alternate exterior. If angle 1, 2, 3, and 4 are exterior and L and M are parallel line, then I'm just going to highlight one of them. Angle 1 and 3 are going to be congruent. You can see that here. Angle 1 and 3 are going to be congruent. So the word alternate means that one of those angles is to the left of the transversal, and angle 3, the other angle, is to the right or to the alternate side of the transversal. But both of them are definitely exterior. And what's so special about them? Well, they're congruent. Second case, alternate interior angles. Once again, the condition here is that both lines be parallel. So I'm going to put the parallel symbol. There we go. This denotes that both lines L and M are parallel. And you can see that here, I'm stating it. So if lines L and M are parallel, what about these interior angles? Well, I'm going to go ahead and pick 2 of them. I'm going to choose angle 5 is going to be congruent to angle 8. You can see that here. So one angle is to the left of the transversal. The other angle, angle 8, is to the right or the alternate side of the transversal, and both of them are interior. What's so special about them? They are congruent. All right. Third special case, called same side interior angles, also known as the consecutive interior angles. All right, so we're dealing with we're looking at same side interior. And what's so special about them? Well, first condition, both lines have to be parallel. So draw the parallel symbol. There it is. So L and M are parallel, and you can see that we denoted that here. If both lines are parallel, then angles like 5 and 7. So I'm going to pick them. Here's 5, here's 7. They're on the same side of the transversal. They're not on alternate sides. One's not on the right and the other one on the left. They're both on the left side. They're both on the same side. Hence, this definition is called the same side interior angles. What about them? They are both going to be supplementary. Remember, the definition of a supplementary angle is that the two angles add up to 180 degrees. Okay, and the fourth and final condition or special case here, they're known as corresponding angles. Okay, so once again, the first condition that we need to satisfy is the fact that both of these lines, L and M, are parallel. So I'm going to draw in the parallel symbols to denote that, and you can see that here. I have stated that if line L and M are parallel, then corresponding angles are congruent. What's a corresponding angle? Well, take a look at angle 1 and angle 7. They're both obtuse and they're both congruent. Now, I'm going to create a visual to help you understand how these angles are congruent and what we mean by corresponding. So I'm going to take angles 1, 2, 5, and 6. Watch this. I'm going to slide them down or move them down. Where will angle 1 land on top? Where will angle 2 land? Angle 5 and 6. If I move them down, right, and I line them up with 7, 8, 3, and 4, you see where they're landing? You see how angle 1 corresponds with angle 7? And you see how angle 2 corresponds with 8. You also see how also angle 5 corresponds with 5. And you can see how angle 6 corresponds with 3. And they are the same angle, the exact same measurement. All right, and that's what they call a corresponding angle. And you can see that being listed right down here. Okay, that's it.